Hello students, in this lecture we are going to start with matrices. I had already shared a handout with you, handout on matrices. So I hope you have gone through this handout completely. I will take you through the handout for 10 minutes and then we will start with the problems from the exercise. Matrices is a newly introduced topic in the CA Foundation syllabus. But so far they have been testing very little from this topic, so I will keep it purely with exam focus for you. Okay, so that is why these I have taken points from the textbook theory, whatever is important for exam, and put it in the handout. So it is more than sufficient if you just go through this handout for the examination, and all the sums that I'm solving the video, if you can follow all the sums and do these problems along with the self practice problems, it is more than sufficient for examination. All I'm asking is, please do not try to go through the theory in the textbook, because it is too much of theory is there and it could be confusing for you. So just go through this handout theory. Okay, as an additional practice you can solve the solved examples in the textbook. Okay, but I will cover the exercise problems completely in these video series for matrices and determinants. Okay, so let's get started with the handout. Let's first understand what is a matrix. Okay, see, matrix is just a form of expression. Okay, for example, see here we have this table with some information: Ram, Sita and Lakshman. So Ram has got books, pencils and pen, all three of them for that matter. Ram, Sita and Lakshman, all three of them have books, pencils and pen. So how many books do they have? 5, 10 and 15 each. 3, 8 and 10 each. 2, 5 and 2 each. So now this is the information that you have. This information, if I put it in the form of a table, okay, or in this format, what have I done? First is 5, 10, 15 for Ram. So first column is Ram, 5, 10, 15. Second column is Sita. First column is books, 5, 10, 15. Second column is pencils, 3, 8, 10. Third column is pen, 2, 5 and 2. Now the first row is Ram, second row is Sita, which is expressed here, third row is Lakshman. Okay, this above information, which is in the form of a table, I have just converted to a matrix. The advantage of matrix is when we see you, I have told you several times in our classroom lectures that when we have a word problem like this, look at this word problem. When we start reading from here up to here, it is more easier when you when you convert this text form to a tabular form. Correct? When you look at this table, at one shot you're getting all the pieces of information. Now the further simplification of this table is this matrix format. So when you express it in this format, it becomes easier to add, subtract, multiply and perform various other operations which matrices help us to do, which we will be seeing in the coming lecture. So now this is the problem that I want you to understand. Conversion of this word problem into the tabular form, conversion of this tabular form into this matrix format. Okay, now let us go to the next. What do you mean by the word order of the matrix? So all of you have understood what is a matrix now. Matrix is nothing but expression in this format with two brackets. Now see, we have written 3 into 3. Why do we say 3 into 3? 3 rows. Row 1, row 2, row 3. So 3, first letter, that first number 3 denotes the row. Second number denotes the columns. So 1, row 1, row 2, row 3. Correct? So the second one denotes the column. So M into N is called as the order of the matrix. So in the above case, 3 into 3 is the order of matrix A, which is mentioned here. Okay. Next we have a rectangular matrix. So is it clear? Order of the matrix is nothing but number of rows into number of columns. So we have 3 rows and 3 columns here. Okay. Next we come to rectangular matrix. What happens in the rectangular matrix? In a rectangular matrix there are m number of rows. Row 1, row 2, row 3, row 4, row m up to here, and columns are n. Okay, so these are the columns. So columns are denoted by n. Okay, n for number, and the rows are denoted by m. M for mall. Okay, that m. So m into n. M denotes rows, n for number denotes columns. Okay, so that is how it is expressed, where the number of rows and columns are not equal. If the rows and columns are not equal, then it is a rectangular matrix. If the rows and columns are equal, then it is called a square matrix. Okay, so when you go through this handout by yourself, it will be more clear for you. You'll be very comfortable, and don't worry, this is very easy. Whatever you have in the foundation syllabus, it's very easy. If you practice adequately, you can be very confident for your examination. Okay, so the above matrix is referred to as the matrix of the order m comma n, or m into n, read as m by n. So how do we read the order of a matrix? We read it by saying m by n. Okay, or we say matrix of the order m comma n. That is another way to say. So there are two ways to say it. One is matrix of the order m comma n, or m into n, that is m by n. Okay, so m denotes the rows, and n for number denotes the columns. And how do we write it? am1 means, look at the last element, am1 means m is the mth row, and 1 denotes the first column. Okay, whereas last element, these are all called elements, each and every item is called as the element. The last one, amn is nothing but m denotes the mth row, and the number n denotes the nth column. Okay, so similarly a1n, first row, nth column, like that. So can you tell me what will be the element in the third row and second column? Third row and second column will be A32. Okay, so 3, 2. That is how we will express it. Now let us go to the different types of matrices. So I have listed down everything here, all the things that you need to know for answering the multiple choice. So the multiple choice here is, what is a row matrix? Row matrix is only one row. Okay, let me write here and show you. A row matrix is something like this: 1, 4, 5, single row. So this is called as a row matrix. Similarly, column matrix. What's a column matrix? You have a single column, 1, 4, 5, only one column. Okay, next we have a zero matrix. What is a zero matrix? Zero matrix is, if every element of a matrix is 0, then it is a 0 or a null matrix. That is, suppose you have a matrix like this: 0, 0, 0, 0, 0, 0, 0, 0, 0. This is called as a null or a zero matrix. Okay, so next we have square matrix. Number of rows and columns are equal. So that is, let's look at this. See, the number of rows and columns are equal. So this is called as the square matrix. Of what order? Can you all guess? 3 rows and 3 columns. So 3 by 3 matrix. That's how we will see. Next, we have a rectangular matrix. Rectangular matrix I just discussed with you, where the rows and columns are not equal to one another. So not equal to symbol we will have to put. Next, let us go to diagonal matrix. Please underline the word square matrix here. All the elements of a square matrix are 0 except on the diagonal. That is, suppose I have a matrix here. Okay, see, first thing is, a diagonal matrix has to be a square matrix. Okay, so it will be something like, sorry, we should not have a 0 here. I am just taking this. This is the diagonal. Okay, this is the diagonal. Okay, now in this diagonal I'm going to write 1, 1 or 1, 2, 3, Let's put 0 here, 0 here, 0 here, 0 here, 0 here. So this is a square matrix and a diagonal matrix. Okay. So where the diagonal, this is called the diagonal of the matrix. This is a non-zero element. Okay. So the next one, scalar matrix. So scalar matrix is nothing but a diagonal matrix. Underline the word diagonal matrix, whose leading diagonal elements are all equal. So suppose I just write the matrix as 2, 2 and 2 on the diagonal. The balance elements are 0, 0, 0, 0. This is nothing but a scalar matrix. Okay. This is nothing but a scalar matrix because the elements on the leading diagonal are all equal. Next, what is a unit matrix? A unit matrix is nothing but whose diagonal elements are all equal to unity. So this is something like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is called as a unit matrix. Okay. So they are all 1, 1, 1, unity. Upper triangular and lower triangular. All the elements above the leading diagonal are 0. Here all the elements below the leading diagonal are 0. So it's something like this. So 1, 0, 0. Here I'll have 2, 1, 0. Let's say 3, 4, 1. Or it could be any other element also. It could be 5 here, it could be 6 here also. So see, all the elements above the leading diagonal are 0. Now this is a upper triangular. This is called as a upper triangular matrix. So all of you know what is a lower triangular now. All the elements below the leading diagonal. So for example, I write the same 1, 6, 5 here. Let me put a 0 here, 0 here, 0 here. Now here I will write 2, 3 and 4. Okay. So all the elements below the leading diagonal are 0. This is called as a lower triangular matrix. Okay. This is a lower triangular matrix. Then, so what is a submatrix? A submatrix is nothing but a matrix which is obtained from a larger matrix. For example, you have this matrix, right? If I delete row 1, suppose I delete this row, okay, what do I get? I get 2, 3, 6, 4, 0, 5. This is a submatrix of the above matrix. Sub of the above. Suppose I call this as the A matrix. So this is the submatrix of the above matrix A. Okay. Next, let's go to singular matrix. Singular matrix, for now, just understand the definition that any square matrix is singular if the determinant is equal to 0. I will tell you what is a determinant and how to find out in the next lecture. So for now you can just learn this. If the determinant is 0, it's a singular matrix. If the determinant is not 0, then it is not a singular. Of course, it has to be a square matrix first. Okay. What about symmetric and what is a skew symmetric matrix? What is a symmetric? What is a symmetric matrix? Okay. So you have a matrix A. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm just randomly writing it. Now A transpose is nothing but, I'm going to rewrite this as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called as the transpose. Okay. What is transpose of a matrix? That is, this 1, 2, 3 became the column, right? This 1, 2, 3 here became the column here. This row became the column here. The third row became the third column here. Now if this is the case, okay, now if suppose when I do the transpose, if A transpose is equal to A, then A is called as a symmetric matrix. I have not given you an example of symmetric, I have just shown you what transpose is. Okay, so it could be something like this. It could be 1 0 3 0 3. Suppose I write something like this. Okay, so if this is your A, then what would happen to the transpose? Let's see. This 103 row will become the column 103. Okay, next row, this will become the next column, next row 3 2 1. Now compare this with the above transpose. Compare each and every 103 103 002 002 321 321. So A transpose is equal to A. Now this is an example of symmetric. Okay, now coming to skew symmetric, suppose A is something like this. Suppose A transpose, if A transpose is equal to minus of A, then A is skew symmetric. Okay, if A transpose is equal to minus of A, that is, if I transpose it here and the transposed value gives me a negative of whatever I have above, then it is a skew symmetric matrix. Okay, how would that happen? That would happen, suppose, let me give you an example like this. Suppose I have suppose I have 1 0 3, 0 and minus 3, 0 and minus 2. Then suppose I have a positive 2 here and I have a 0 here. Okay, this is A. Now what is A transpose? Go row by row, go to the first row, convert it to column, second row, convert it to column, third row, convert it to column. Now compare these two, compare this and this. Look at the first element. The first element is not 0, so why don't I make this as a 0? Okay, then this would also be 0. That will be better. Now you can compare this and this. This element was 3, this has become minus 3. This element was minus 2, it has become plus 2. This element was minus 3, it has become plus 3. This element was 2 and this has become minus 2. So can we say A transpose is nothing but negative of A? Therefore A is nothing but skew symmetric. Okay, so I hope you've got the idea or basic of what are the different types of matrices. So these are all the different types of matrices that we have here. Let us go to what is meant by equal matrix. Equal matrices are two matrices. You have any two matrices, they can be called as equal only if their order is same, which means the rows and columns in A is the same as the rows and columns in B. Okay, you have two matrices. Let's say you have matrix A and you have matrix A, B. So let's say 1 2 3 3 2 1 4 5 6. Suppose here also you have 1 2 3 3 2 1 4 5 6. The order is same. This is also a 3 by 3. This is also a 3 by 3. Correct? The order is same in both the cases, and also the elements are equal. both are same. Therefore, matrix A is equal to matrix B. Okay. Next, addition and subtraction of matrices. Okay, you can, any two matrix given to you, you can add and subtract. Okay, you can do both the operations, but only one condition, both should have the same order. That is, the number of columns here and the number of columns here are same, the number of rows here and the number of rows here are the same. If only when that is same can you add and subtract both of them. Is it clear so far? Now let us, I have not done the multiplication part here. I'll come to that later. Okay, first whatever we have done so far, with that I'm going to go to the problems in your textbook. Please open unit 2 exercise A in your textbook. So let's go to the first question. What does the first question say? If a matrix has 16 elements, what are the possible orders? See, when can a matrix have 16 elements? It can have 16 elements when the number of rows into the column, right? For example, here I have this matrix with 3 rows and 3 columns. How many elements are there? 9. So 9 elements, 3 into 3, 9 elements. How many elements are there here? 3 into 3, 9, right? So let me give you another example. 1, 2, 3, 4, 5, 6. This is how many rows? 2 rows. How many columns? 3. 2 3s are 6 elements. So that's how we get the number of elements. So in this case, if you have 16 elements, then what are the possibilities? Number of rows could be 2 and columns could be 8, or number of rows could be 8 and columns could be 2, or there could be 1 row and 16 columns, or there could be 16 rows in each row having just 1. Correct? These are the 4 possibilities. So we have to check for this in the options. So here you have 2 into 8, but it is 8 into 1. This is not true. I missed 4 into 4. So that is also to be included. Anyway, option A is to be eliminated because it says 8 into 1. So come to this. 2 into 8, 8 into 2, 4 into 4, 1 into 16, 16 into 1, all are satisfying. So we will go with option B. Okay, we'll go with option B, whereas C and D both have an error in it. 4 into 1 instead of 4 into 4. It has 2 into 4 also, so both have an error. Only option B is correct. So we will go with option B. I missed 4 into 4. 4 4s are 16. That should also be mentioned, right? This is the first question. Let's go to the next one. Transpose of a rectangular matrix will be a rectangular matrix. See, for example, you have a rectangular matrix. This is a rectangular matrix, yes or no? If I transpose this, I will get 1, 2, 3, 4, 5, 6. So what is the number of elements? 3 rows and 2 columns. So this is also a rectangular matrix. This is also a rectangular matrix. So the answer for the second question is option A, I guess, right? A was the one with rectangular. Okay, let's go to the third one. Transpose of a row matrix will be a column matrix, because when you have a row matrix, there is just a single row. Okay, third question, there is just one row, 1, 2, 3. When you transpose this, it becomes 1, 2 and 3. So a row matrix becomes a column matrix. Okay, so next, come to the next one. Fourth question we will leave for the time being. I'll come back to it because it talks about multiplication. Okay, so we'll come back to the fourth question. Now come to this fifth question. Fifth question says if A is equal, determinant of A is equal to 0, then A is a singular matrix. A is a singular matrix. Option B. Option B. I have taught you that in the handout. Okay. Then coming to the sixth one. If A is a symmetric matrix, then transpose of A is A. A transpose is nothing but A itself. So the answer is option A. Let's go to the seventh question. Okay, seventh one, we will come to the seventh one when we learn multiplication. So I will have to do question number 4 and question number 7 for you when we do multiplication. Question number 8 also we will do after we learn multiplication. Question number 9 we will do later when we do determinants. Okay, I have not yet done determinants for you, so just leave it. Straight you come to question number 12. Okay, so we'll start with 12. Up to there I will do, up to question number 11 I will do later in a later video. So now come to 12. We are going to do simple things, addition, subtraction of matrices. Okay. So come to 12th question. You want to find A plus B. Now when can we find A plus B? We can find A plus B only when your matrix A and when your matrix B both have the same order. So check, do they have the same order? A is a 2 by 2, B is also a 2 by 2. So they can be added. Okay. So how do we add it? Okay, be very careful. We have to add it element by element. Let me write here 2 minus 3, 4 and 5. 2 minus 3, 4 and 5. This is what? This is your A. And what is your B? Let us write that also down. 1, 5, 6 and minus 7. 1, 5, 6 and minus 7. Now we are going to do A plus B. A plus B is adding each and every element. 2 plus 1 is 3. Minus 3 plus 5 is positive 2. 4 plus 6 is 10. 5 plus minus 7 is minus 2. So that's all. A plus B is that simple. Okay. So what you have is, check the options. You need 3, 2, 10 and minus 2. 3, 2, 10 and minus 2. Option A. Option A is your answer. Now 13th one, you're going to find out A minus B. Instead of adding, you just have to subtract. So I am going to leave this for your self-practice. Okay. Let's go to the next question. Fourteenth one. I'm going to show you the 14th one now. 3A minus C we are going to do. Okay. So the 14th one talks about 3A minus C. So first I'm going to write down what is 3A. 3A is nothing but, I have this matrix here, right? 2 minus 3, 4 and 5. I'm going to multiply it with 3. So what is 2 3s are? 6. 3 3s are minus 9. 4 3s are 12. 5 3s are 15. So this is my 3A. Okay. And what is my C? C is in the question. I have to take it down from the question. C is here 2 5 3 4. 2 5 3 4. Now let us find out 3A minus C is equal to 6 minus 2 is 4. Minus 9 minus 5 is minus 14. 12 minus 3 is 9. 15 minus 4 is 11. Okay. Now we are done with question number 14. 15 and 16 are multiplication. I am going to do 15 and 16 when we learn multiplication. Okay. 17th one I'm going to leave for your self practice. 17th one is nothing but, sorry, 1 minute. 17th one, there is a small printing error. 17th one is nothing but, it is not a plus here. Here it's not a plus. It is a, this is not a plus between the two matrices. The symbol is multiplication. Okay, so it is multiplication. We'll do it when we do multiplication. 18th one I will leave it for your self practice. Okay, all you have to do is addition. It is going to be very simple. You just have to add it element by element. For example, the first element will be a square plus b square minus 2ab. What is a square plus b square minus 2ab? A minus b the whole square. Okay, let's see if we have that. A minus b the whole square is in option B. Is it there in any other option? It's there in C also, it's there in D also. So we eliminate option A. Similarly, you can check the next element. Okay, b square plus c square minus 2bc. That is nothing but b minus c the whole square. We have eliminated option A. B minus C is not there in this, so option B is also eliminated. We are left with only C and D here. Okay, now in C and D, just check one thing. This is common, right? A plus B the whole square is common. This is also common. So just check for A plus C the whole square. Just check for this element. What does it say? It is nothing but A square plus C square plus 2AC, which is nothing but A plus C the whole square. So where do you have it? Only in option C, right? So answer for the 18th one is option C. Easy. So see, what we have done in today's lecture are kind of questions which do come in the examination. Although this is an introduction video, these kind of questions can also be very much expected. You don't get very tough questions from this chapter. Like I told you, it was newly introduced in the foundation syllabus very recently. So you can score full marks in this chapter. Okay. So what are the self-practice problems that I have given you in this video? I have given you 13, 18 I have solved, but you can still try by yourself, and 19. So effectively 2 problems, 13 and 19 you can try on your own. Okay students. Let's see if there is any other problem which may be, oh yeah, problem number 19 I have given you. You can try maybe question number, you can try question number 34 as homework. Okay, it's a very simple, straightforward problem. Question number 34. So see you all in the next video where I'm going to teach matrix multiplication. So the next video is going to be only on matrix multiplication, and that is a very important part of matrix, this chapter, because this is also very often tested in the examination. And some portion of it, I'm going to, like I told you, I'm going to take it very exam centric. So I'm going to break this into 4 videos or maybe more if required. The first is just the introduction. The second one is going to be on matrix multiplication. The third one is going to be on determinants, how to compute determinants. The fourth one is going to be some applications like Cramer's rule and so on and so forth. Okay, so see you all. Happy learning. Keep asking your doubts through WhatsApp messages or through your comments. Okay.